Alright, this is the 5th video in the series of factoring polynomials from 5.5 to 5.7, and this is subject or topic is in 5.7. We're going to talk some more about more three-term polynomials. Something that I want to make sure to point out that for all three-term polynomials you can use synthetic factoring, and I'll talk about that in a later video, but I just want you to know that. But so why am I teaching you about perfect square trinomials? So we are talking about three-term polynomials that are perfect squares. Well, first of all, what is a perfect square? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared, could do this all day, is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. We keep going. You should probably know these all the way to 15, which would be 225. Okay, so what is a perfect square? Well, these are perfect squares. These numbers here and here are perfect squares. They're numbers that can be factored to something times itself. Okay, so the definition of a perfect square trinomial is that the front end is a perfect square, the back end is a perfect square, and the middle is 2 times their root multiplied together. That might be confusing, so let's go through and look at these. So again, these are the magic numbers you want to have memorized so that you can go, oh my gosh, those are perfect squares. Okay, so I'm going to look here, and I'm going to say, well, I could actually do this with hippobutts, so I'm going to show you this. I could factor this with a hippobutts, and I could say hippobutts, hippobutts. The last number is what times what? Oh, they're going to be both 3's. And oh my gosh, 3 times 3 is 9, and 3 plus 3 is 6, and that works out. You can see that this factors, there's 2 of these same factor, which you would write like this. Okay, well, we could have skipped this hippobutts step if I had recognized that this was a perfect square trinomial. This is a perfect square, and so is this. And if I were to write the root of w squared, it would be w. And if I were to write the root of 9, it would be 3. Well, the sign right here is going to go right here. And 3 times w is 3w. If I double this, that's equal to 6w. Sure enough, that is the middle term. That is the definition of a perfect square trinomial. The a times the b doubled is the middle term. And if that's the case, then this just drops in like this. Okay, but I could also use synthetic factoring for this. I could say my first step is a times c. So this is going to be positive 1 times a positive 9, which is going to give me a positive 9. Factors of positive 9 that sum to 6 are both 3. I'm going to write those over the coefficient of 1, the coefficient of my w squared term. And so this is step 2, this is step 3. Step 4 is that I'm going to reduce these fractions. Well, they're already reduced. And I'm going to rewrite these as factors. That is going to be a w plus 3 and a w plus 3. And you can see the factors are the same. They're factors that repeat themselves. Again, this is going to simplify to w plus 3 squared. So I just showed you 3 ways. You can hippobutts this, you can use this formula, and you can use synthetic factoring. So you can kind of pick and choose, but perfect square trinomials are nice for when you don't recognize what they are, or if it's not a hippobutts. So when I'm looking at this one, I'm like 16, 40, they have like 4 in common, but 25 doesn't. There's no common factor, so checking for my greatest common factor out the gate. Now I'm going to say this is a 3-term polynomial. Well, dang it, if I didn't know about perfect square trinomials, I would say that I'm looking for, I'm going to use synthetic factoring because this coefficient is greater than, not equal to 1, and it's not a GCF. So if I started doing, my synthetic factoring here, I would say a times c and I would get a positive 400. Then I have to find factors of 400 that are going to sum to a negative 40. Well, good grief. I could be listing these all day. It could be like 1 and 400, 2 and 200. 3 doesn't go into that. 4 and 100, 5 and oh, seriously, I could be doing this all day. And maybe some of you see right off that it's 20 and 20. Well, anytime you see that they're the same factors that will sum, so a negative 20 and negative 20, stop. Stop right here and say, oh my gosh, this is a perfect square trinomial. Okay, well then what is the root of this first term? Oh, okay, the root of the first term, well, 4 times 4 is 16. Z squared times z squared is z to the 4th. That's the first term. The last term is the root of 25. That's going to be 5. And the sign is going to be this sign right here, always. This sign. Okay, so it's going to be minus. And I'm going to square this. This is a binomial squared. Again, whatever sign is right here is going to match when you factor. The sooner you recognize these perfect square trinomials, the better. And anytime you get like this mondo huge number when you're using synthetic factoring, you might want to stop and say, wait a minute, this might be a perfect square trinomial.